today, what we are going to learn is the basic equation involved in hydrostatic force in plane surface. So I will draw to you three different conditions that may happen, and the condition is based on the angle of theta. Okay, so assuming this is a surface, okay, and the triangle over here is showing that this is surface and meeting atmosphere. So what happened here is, I will give you three different conditions. Number one, a tilting body, okay, and then with a certain angle theta. And then number two, it will be a vertical body, also with a angle of 90 degree here, okay. And the last one will be a horizontal body, and this is also 90 degree. Alright, so the basic equation that you need to find out is, first thing is you need to know what is the YC. Okay, so YC is the location of your center of gravity, which is here. If this is your center of gravity, this point, okay, what we want to locate is the distance between the center of gravity up until the surface. As usual, I bring this a bit offset to the bottom because we don't want to overlap all the writings over here. Okay, so this will be your YCG, and this is the S, which is the distance between the tip of the plate to the surface of the liquid. Okay, so from the tip of the plate to the surface of the liquid is S, and S and YCG or YC is dependent on theta. Okay, so for YC, the equation is equal to S plus the centroid for our plate. And the centroid of the plate is dependent on the shape of the area of the surface. Okay, if the shape is a rectangular, so the centroid will be, for this one, is B over 2. So what is V? B is the distance between the top part of the plate to the bottom part. Okay, so what is the meaning of centroid or the area of surface? The area of surface is the surface area that is can be denoted like this. For example, if this is a rectangular, so this is the area of surface. Okay, and the area of surface is this part. The B that we are calculating is this B. Okay, this is the width of the body, which is usually denoted as W. Okay, and then we have width, we have B over here. Okay, and then what we need to find out is the centroid. So the centroid, if the surface is like this, should be somewhere here in between. So it is here and it is here. So basically, it's in the middle of the surface. Okay. Okay, so that's B over 2. If it's a triangle, for example, like this, it will be dependent on the shape of the triangle. If the shape of the triangle is like this, the centroid will be a bit lower. So it will be from this part to this part. It is 2B over 3. If the shape of the triangle is this one, so it's a bit on the top, so the distance should be B over 3. And if you have a circle condition, so the centroid will be D over 2 here, a bit here, somewhere in the middle. Okay, so the centroid is dependent on where is the location of the centroid and the surface that we are seeing right now. Okay, so centroid is D over 2 for square, for circle. For a rectangular, it's B over 2. Shape like this is 2B over 3. And the triangular shape, if it's upside down like this, is B over 3. So make sure you put the right centroid depending on the surface that we have on top. Okay. All right, so when we get YC, we will have the location of your YCG. In case you want to know what is the vertical location, for example, this is YCG, and the vertical location is like this, which is can also be called as HC. Okay, so to find out what is your HC, it's just an equation that looks like this. HC is YC sine theta. Okay, how do we get this? This is from trigonometry, because when you have this as YC and this as HC and this is theta, okay? So because the theta over there is the same as theta over here, so we use sine theta equals to HC over YC. So your HC is equal to YC sine theta. Okay, so depending on the question, if the question asks us what is YC, so YC is this distance over here, so we can just find it through S plus centroid. Okay, however, if they ask you what is the vertical height, it should be HC. So HC can be found using this equation over here, YC sine theta. All right, when you find out what is YC, you want to find out where is your center of pressure. So your center of pressure is called YP. Okay, and the center of pressure is equal to YP and equal to YC plus IXXC, second moment of inertia in the XX plane, okay, divided by YCA, right? And remember, this equation is happening because we assume we are doing everything in terms of gauge pressure. Okay, so we don't include any ATM pressure. If not, this equation will have an additional ATM combination inside, right? But for the purpose of our study or calculation, we will use this equation for all hydrostatic force in plane surface question, all right? So for YP, it's just YC plus IXXC. So the IXXC is also dependent on the surface area. If it's a rectangular surface, it is LB cubed over 12. Or we can usually L can be A or whatever notation, but it is actually the width depending on the question. Okay, so usually for hydrostatic force, we use A, but L can also be there also, or W can also be used for it also. Okay, for triangular shape, doesn't matter whether the triangular is upside down or straight up like that, it will be equal to AB cubed over 36. And for a circle, it is equal to pi r4 over 4. Okay, so this is not something new because all this second moment of inertia can actually be calculated when you are studying your static. Okay, so for static, we already see this kind of equation. So this is just something that you just need to remind back, okay, coming from that particular subject. All right, so you get your IXXC, and then from your IXXC, you can add in your IXXC over here, and the numbers for YC and also A. So to give you what is the area of surface, it's also dependent on the design. Rectangular should be A times B. A triangular shape should be AB divided by 2. And a circular shape should be pi r square. Or for me, usually I use pi d square over 4. All right. So moving on from there, the final part is usually we will ask you what is the FR. FR is the resultant force, and it can be calculated using this equation, rho g h c multiplying by A, because the idea of F is equal to pressure times area. Okay. So by using that, you can actually find Fr, and the area can be calculated using the same area that we use over here and also here. Okay. Area all together. Okay. So what's the difference between the tilted part, tilting plane, vertical, and also horizontal? Okay, the differences between all those things are related to one thing, which is theta. Theta can be anywhere from 1 until 90 degree. Okay, for tilting. Or for me, I guess it's more on 89 degree like this. Vertical, the theta is 90 degree. Horizontal, the theta is 90 degree. So for tilting and vertical plate, we will use all this equation that I've given to you just now. Okay? So this equation can be used. Okay? And also we use all the equation up until Fr like this. But for horizontal, we don't have to find out what is your YC. We don't have to find out what is your YP. We just have to find what is your Fr. Why? Because the location for the surface should be similar from one point to another because it is a flat horizontal surface. For these two, the surface is different in depth, meaning going deeper, the pressure will increase. Because of that, we need to do this calculation, including finding YC, finding YP, before we can do the FR. For horizontal, we can just do the FR, rho G HCA, and the HC comes from this distance over here, from the surface to the top part of your plate. Okay, so for these two, reminder, you need to do the YC, the YP, and the FR. But for vertical, because theta is 90 degree, so sine 90 degree is equal to 1. Okay. Why is it important to know this? Because when we do FR, FR is equal to rho G HCA. So if you have a tilting plate, okay, the rho G HCA can become rho G YC sine theta A. For the vertical plate, the rho G, the FR will be rho G YC sine 90 degree A. If you do sine 90 degree A, it is actually equal to 1. Okay, so for vertical, center of gravity is here. For horizontal, we don't have any calculation on center of gravity. And your YP, for example, for this question, will be a bit lower than the YCG. This is center of pressure. This is also the same here for center of pressure. It should be a bit lower than the center of gravity. Because center of gravity of body will never change, but center of pressure will change depending on the depth of the liquid or the depth of the plate itself. Okay, so this is the basic equation used for this particular study.